question is, the diode incremental resistance for the circuit below is. We know that the dynamic resistance of a diode is given as eta Vt by the diode current ID. Here the diode current ID is given as 10 minus 0.7 divided by 10k. So if we substitute 2 into 26 into 10 power minus 3, here this is 9.3, that is 0.93 into 10 power minus 3, we will get this as 53.8 ohms, hence option B is correct. Here the question is, for the circuit shown below, we have to find out the output expression in terms of ABC. Here, in general, the transmission gate, suppose this is taken. Here, suppose this is X, this is Z, this is Y, this is Z. Means the output expression is going to be XZ plus XZ bar, which is nothing but X. Means if Z equals to 0, this is going to be turned on. If Z is equals to 1, the NMOS is going to be turned on. Similarly, see, if we draw a truth table for this, A, B, C, Y. If 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So output expression Y is, suppose if C is 1. So if C is 1, which one A is going to be passed to the output. So this is 0, this is 0, 1, 1. If C is 0, if C is 0 means B is going to be passed 0, 1, 0, 1. So if we solve the expression, that is for Y in terms of ABC, A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1. If we group these two, so Y is going to be BC bar plus AC. Hence option B is correct. Here the question is, the one transistor dynamic ramp cell is shown below. Choose the correct statement. Here CS is the source capacitance, B is the bitline capacitance. For the perfect operation as a memory cell, the value of source capacitance must be greater than the bitline capacitance, that is option A is correct. Question is, the gain at the center frequency for the band pass filter shown in the figure below. Here for the band pass filter, the transfer function is some constant P multiplied with S square omega naught by Q S plus omega naught square. At the magnitude of the transfer function at S equals to j omega naught is going to be Ps omega naught divided by omega naught square divided by Q square. Hence here see, at the magnitude is equals to P omega naught divided by, this is S if we substitute, minus omega square plus omega naught square plus j omega naught square by q. The magnitude is going to be p omega naught minus omega square whole square plus omega naught square by q whole square under root. At j equals to omega naught, it is going to be pq by omega naught. So this is the magnitude. Now what we have to do is, the gain for this particular filter is minus ZF by Z1, whereas ZF is R2 parallel with 1 by SC2, Z1 is R1 parallel with 1 by SC1. Okay, so if we, after getting the transfer function from this, then if we derive these values, we are going to get the gain at the center frequency as option D is the correct answer. Question is, in the circuit shown below, beta for the BJT is 99 and assuming the thermal voltage to be 50 millivolts, calculate the input resistance. Here Rin is going to be HIE plus beta plus 1 to the emitter lead resistance, means the resistance seen from here is Re. Here Re is nothing but 200 plus 200 ohms plus 1 by Gm of the transistor. So Gm is, we know that IC by Vt. Here IC is nothing but alpha IE by Vt. Here IE is 0.4 milliamps, Vt is 50 millivolts, alpha is beta by beta plus 1. Okay. From this we will get the Gm. After getting the Gm, we know that Gm is nothing but beta by HIE. So from this, HIE is beta by Gm. So after getting the Gm, Re is given. So we got HIE, we got Re, we know beta, we know this, all those things. If we calculate, we will get Rn as 65 kilo ohms. Hence option D is correct. Question is, for the system shown in figure below, E of t is the error between the input and the output Y of t. If x of t equals to tu of t and all the initial conditions are 0, then E of t will be. See here, if we apply the Laplace transform to the second order equation shown in s square y of s is nothing but minus E of s. Okay. Now E of s is going to be y of s minus x of s. So y of s is minus E of s by s square is 1 by s square. So E of s 1 plus 1 by s square 1 by s square. So E of s is minus 1 by 1 plus s square plus 1, which is nothing but, if we apply the inverse Laplace transform, that is E of t is minus sin t, hence option